Okay, let's do this. Shoelace. Where are we at? Have to get in this. Evaluating composite functions using tables.
So we have some tables here that give us what the function f, what the functions f and g are when you give it certain inputs. So when you input -4, f of -4 is 29. That's going to be the output of that function. And so we have that for both f and g. And what I want to do is evaluate two composite functions. I want to evaluate f of g of 0, and I want to evaluate g of f of 0. So like always, pause the video and see if you can figure it out. What's first?
F G0. So here we talk 5, and then here it's 11. This is 11. So this is 11. And this f of 0 is 1. So 1 here is 8, and this is 8.
Let's think about f of g of 0. F of g of 0. What is this all about? And actually, let me use multiple colors here. F of g of 0. Well, this means that we're going to evaluate g at 0. So we're going to input 0 into g. Do it in that. So we're going to input 0 into our function g, and we're going to output whatever we output is going to be g of 0, all right over here, and then we're going to input that into our function f. We're going to input that into our function f, and whatever I output then is going to be f of g of 0. F of g of 0. F of g of 0, with these small here, so we have space for the actual values. So first, let's just evaluate. And if you are now inspired, pause the video again and see if you can solve it. Although if you solved it the first time, you don't have to do that now. Well, what's g of 0? Well, when we input x equals 0, we get g of 0 is equal to 5. So g of 0 is 5. So that is 5. So we're now going to input 5 into our function f. We're essentially going to evaluate f of 5. So when you input 5 into our function, 5 is equal to 11.
Okay.
So this is how it's evaluated. F of 0. G first. So then you get that f of z, and then the output of that is going to be g of f of 0. So let's see. What the table tells us that f of 0 is equal to 1. So f of g of 1. Because once again, f of 0 is 1. This is equal to 8. And we're done. And notice, these are different values because these are different composite functions. F of g of 0 is 1.
Okay.
So we have the graphs of two functions here. We have the graph y equals f of x, and we have the graph y is equal to g of x. And what I want to do in this video is evaluate what g of f of f, let me do the f of in another color, f of -5 is. F of -5.
So f -5. Wait, f of -5. So this is the y, this is the x. F of -5, this is 1. F of -5. Okay. To 5 equal the y, then equal, this is the x, f of x, wait, -5, this is -5. So what's the y equal? It's not even -5. It's between. doesn't touch the minus 5.
And it can sometimes seem a little daunting when you see these composite functions. You're evaluating the function g at f of negative 5. What does all this mean? And you just have to remind ourselves what functions are all about. They take an input and they give you an output. So really what we're doing is we're going to take, we have the function f, we're going to input negative 5 into that function. We're going to input negative 5 into that function. And it's going to output f of negative 5. It's going to output f of negative 5, and we could figure out what that is. And then that's going to be the input into the function g. So that's going to be the input into the function g. And so we're going to, and then the output is going to be g of f of negative 5. G of f of negative 5. Let's just do it step by step. So the first thing we want to figure out is, what is the function f when x is equal to negative 5? What is f of negative 5? Well, we just have to see when x is equal to negative 5, the function is right over here. Let's see, let me see if I can draw a straight line. So when x is equal to negative 5, the function is right over here. It looks like f of negative 5 is equal to negative 2. It's equal to negative 2. You see that right over there. So f of negative 5 is negative 2. And so we can now think of this, instead of saying g of f of negative 5, we could say, well, f of negative 5 is just negative 2. So this is going to be equivalent to g of negative 2. g of negative 2. We're going to take negative 2 into g, and we're going to output g of negative 2. So we're taking that output, negative 2, and we're inputting into g. So when x is negative 2, what is g? So we see, when x is negative 2, g, the graph is right over there, g of negative 2 is 1. So this is going to be 1. So g of f of negative 5 sounds really complicated. We were able to figure out is 1. Because you input negative 5 into f, it outputs negative 2. And then you input negative 2 into g, it outputs 1. And we're all done.
Okay. The tables below show some inputs and outputs of functions f and g. The tables below show some inputs and outputs of functions f and g. Okay. F composite of g, 12, okay, G12, then minus 8. So minus 8 is 16, 16. Okay, the graph of the equation y f x and y, okay, f x and y hx are shown in the grid below. Which of the following best approximates the value f h of minus 5? So h minus 5, here it says h, this one is h, h minus 5, where the x is minus 5, this is the x, this is minus 5, is minus 2. So if we plug in minus 2 here, the x is minus 2, we're coming here. Would you say 3? I'd say so, 3. Okay. The graphs of the equation y, x and y. Okay. Which of the following is the best approximates of the value g of f2? So g2, and this is g. So it's here and 2, Let's say 6, perhaps 6, 5. I don't think it's a 5. It's a 6. Let's go with 6. So 6 here in the x-axis, 6 here. You say 7? So this is 2 dot to 6. Here 2 goes up. No, 6. 6. 6 is here. I don't think it touches. Did you say it's 7? It doesn't touch, but I don't know. No. So again, G F2. Oh, F2. G of F2. So we're starting with F. This is F. Starting here 2. That's 2 is 6. And here 6 is 4. It's minus 4. No. Minus 3 then. So what did we say? 2. 2 F2. 2. 6. Must be 6. But 6 here. Minus 3. Minus 3. Okay. What's the outputs of functions g and h? G, h. So h minus 3. Where's the h? Minus 3. 2. Plug it to the g. 7. Are you giving me no graphs? Probably knows that I dislike graphs, but I have to enforce myself into learning graphs because it's important. You know where I get lost? Hyperbola, parabola, oh my god, those things. Oh my god. Oh, god damn it. Tangent, oh my god. God damn it. Okay. F minus 1. F minus 1. F minus 1 is minus 6. Minus 6. And the G is minus 10. Minus 10. Bonus. No bonus. Is this enough for today? Find the composite functions. Finding composite function. Find composite functions. Okay. No. Didn't see.
We we first got introduced to function composition, we looked at actually evaluating functions at a point, or compositions of functions at a point. What I want to do in this video is come up with expressions that define a function composition. So for example, I want to figure out what is f of g of x. F of g of x. And I encourage you to pause the video and try to think about it on your own.
Yep, it's gonna be it's gonna be let's say, god damn it, fx equal, or fg of x equal this, the x square is gonna be x over 1 plus x squared minus 1. So to go with this. So the
g of x in this case is the input to f of x. So wherever we see the x in this definition, that's the input. So we're going to replace the input with g of x. We're going to replace the x with g of x. So fx is also a function of x. So f of g of x is the square root of, and we could write this as x squared over 1 plus x squared, but we can just leave it like this. It's equal to the square root of this whole thing, x over 1 plus x squared minus 1. Now let's go the other way around. What is g of f of x? What is g of f of x? And once again,
here it's going to be over 1 plus this one.
I encourage you to pause the video. F of x is now the index you will over, I'm doing the same colors, plus f equal to squared minus 1. So it's going to be that over 1 plus the position f of g of x. You get this thing. This is g of, these are very
exercise. Let's do this. F of hx, so this is hx, this is f, it's gonna be quadratic. Oh my god, what are we doing here? So f of h of x h of x equal, so it's gonna be quadratic root 2x minus 15 all over to the power of 3 minus 6, and this will go with this, so it's gonna be equal 2x minus 15 and minus 6, that's a minus 21. So 2x minus 21 x minus 21. Okay. F of g of x as an expression in terms of x of g of x, so this is g of x, we'll go on fx here, it's gonna be two minus 18 minus 3x, and also over 18 minus 3x minus, wait, plus 1. Can it go over? Yes, it can, because minus 2 and minus, so this will be, this is where it gets confusing. This minus means that everything here is gonna be from the discrete, the counter, I don't know, it's just flip the signs. So it's gonna be 2 as it is. This minus will go to 18. 18 here is positive, so minus 18. And flip the signs, this minus and minus is gonna be positive 3x. And here just it's gonna be 18 minus 3x plus 1 plus 1. Nothing will change because this positive means that is the same, no flipping signs. So 2 minus and minus 18 is gonna be, is gonna be minus 16. No, oh my god, oh my god, minus 16 plus 3x, am I correct? Plus 3x over 18 plus 1, so this is gonna be, we could write it either ways we want, but it could be minus 3x plus 19 or 19 minus 3x. So we're gonna say 19 minus 3x. Either ways. I need this to be minus 16 plus 3x minus 16 plus 3. Oh, wait. We can do even further. Plus 3x over minus 3x You know, we could do it further. If this was plus 3x, this will go with this. But because it's 1. But since it's minus 1. It's minus 1. So it's going to be minus 16 over 19 minus 1. Could this even go further? I think so. It's going to be equal, let's say, minus 16 is 8 over 19. Nope, I don't think so. That's 18. Nope. It can't be. Can it be divided? Can we divide it by 3? 16. 16 over 3. I don't think so. 16 over 3. That's 18. 6. Not 16. 16. Can it? Can you divide it by 3? 16. Nope. So 16 over 19. It's a 16 over 19. So it's gonna be how to delete this? Yep, 16 over, okay, it's gonna be minus 16. Where's the over sign? God damn it. There is no over sign. Where's the division? Oh, we could use this. Okay. Okay. So we say minus 16 over 19. And then here, minus 1. Would you say? Nope. He doesn't like it, so it's gonna be here, we'll go here, plus 3x, and here, minus 3x. Oh yeah? Okay. G of h of x, G of h of x, so it's gonna be x, oh my god, x squared minus 1 all to the power of 2 plus 6x squared minus 1 is to the power of 2, just like we said in earlier videos. A minus b, I think, all squared is equal to a squared minus 2a b plus b squared. So it's gonna be x to the power of 4, because 2 and 2 just plain, and minus 2x squared minus 2x squared and minus 2 minus 1, sorry, minus 1, because you know it's just minus 1, not minus 1. This is gonna be minus minus, because 2x squared multiplied in minus 1 is gonna be minus, so this is minus, so we have minus minus plus 6 squared, which is 6, I think it's 36, 6 squared is 36, this is 36, so it's gonna be, and plus here the 6 plus 6x squared minus 6. Am I right? There is no, yep, so it's gonna be here x to the power of 4. This is minus minus, so this is plus, so this is actually a plus sign here, so 2x squared plus 6x squared is 8x squared, and I got plus 336 and minus 6, that's plus 30. So I'd go with this answer, and x to the power of 4, wait, what was it? It was x to the power 4, come here, that's it, plus, nope, that's it, we're finished. How to say Yeah, go down. Okay, plus, what did we say? 8x squared. 8x. Oh yeah. Nope, we don't need this. Or let's see. Wait. This is wrong by all means. Yep. And then plus 30, did we say? Am I correct? Plus 30. Yeah, it doesn't. What did we say? X. So we'll go at it again. Give me a new page, baby. Give me a new page. We'll go at it again. X squared minus 1 all to the power of 2. And there is plus 6 over or multiplied by x squared minus 1. We'll do it the hard way, no. The long way, I mean. X squared minus 1 multiplied by x squared minus 1. Okay. X squared dot x squared by whatever multiplied by x squared is x to the power of 4. X squared to minus 1 is minus x squared, and then minus 1 over x squared is minus x squared. Minus 1, that's minus 1 multiplied by minus 1, that's plus 1. So it's gonna be give us x to the power 4 minus 2 x squared plus 1, and there will go 6 plus 6 squared plus, and 6 to the minus 1 is minus 6. So we got, okay, here it is, x to the power of 4 minus 2 and plus 6 is plus 4x squared, and then we got plus 1 and minus 6 is minus 5. So how did we get here? How did we get this? Where did I go wrong? I would say here, but let's see. Nope, not this one. Where did I go wrong? This a minus b all square is a square minus 2ab minus 2ab. It is minus 2 plus b squared. How did this become 36? How did this become 36? I don't know. B squared, it's a b. I took this as a 6 square. This is okay. Again, b squared. Again, let's do this way. You see, dear viewer, I'm doing this for me, so wasting your time is not my priority. So again, I get x squared to the power of 2 minus 2 multiplied by x square multiplied by minus 1, and I got b square, which is minus 1 square, which is plus 1. So where did I go wrong? I think I went wrong in this sign. Am I correct? Because this is gonna be x4 plus 2x square plus 1. So I must have, well, yep, it's the sign. Plus 1. It's the sign. Get the minus and the minus. It's a minus 4x. That's a minus. Let's write it here. It's written here. It's x squared minus 2x squared plus 1. And what I got is x to the power of 4 plus 2x squared plus 1. So this minus doesn't mean, I swear to God, I remember it's this minus, but let's check our answer here. How's it gonna be if this answer is correct? Okay, x to the power of 4 minus 2, that's a plus 4. Wait, this is x, correct? Yep, I got plus 4x squared minus 5. Let's check. X, this is 4, and this minus 5, minus 5. Oh yeah, so this is a plus, this is a plus. That's because if this was a plus, then this would be plus and 2 and minus 1. It's gonna make it negative. So let's take this to chat, to Claude, to check it out. Sign in the middle term is wrong. It's a minus. For fuck's sake, it's a minus. It's a minus, so where did I go wrong? Okay. minus 2. It's a multiplication, for fuck's sake. Oh my god. It's a multiplication, so this is minus 2 multiplied by minus 1 is plus 2x to the power of 2. It's a multiplication. I was adding minus 2 and minus 1. That's not it. It's a multiplication. Minus multiplied by minus is a positive. So yeah. Anyways, let's go back. Next question. G comes of f(x) as an expression in terms of x. Got 7x plus 2 to the power of 2, and I got 7 of x plus 2 minus 5, and this, just as we know from that, the same thing, a plus b squared equal a squared plus 2ab plus b squared, because the sign here is positive, so this is positive. When this is negative, this is negative. So what we have here is 7x squared. This is the a. I got plus 2 multiplied in 7x multiplied in 2 plus 2 squared. God damn it. 2 squared. That's over 7x plus 2 and minus 5. 7x plus 2 and minus, that's a minus 3. And this, let's do this multiplication. What is going to be? 2, 4, 4, and 7. 4 multiplied by 7. 7, 14. 7, 7, 14. That's 28. 28x. Am I correct? Okay. 2 multiplied by 2 multiplied by 7. That's a 28. So I got 7x squared first. Let's get this. And then 7x to the power, what is it? Here, power 2. Can we, this is minus 3, 7x. I think we can. 28x over 7x. Is 4. But I can't get rid of the x though. There's a problem I'm facing. 4 of 7x is gonna give me 28x, but I cannot get rid of the x here. So it's gonna be 4x. Let's say 4x. Let's try. Plus 4x plus, what did you say here? 4 plus 4 over minus 3. Would you say that that checks out? Nope. So it's going to be 28.6, and this is 7x. 7x. So I got 7x squared plus 28x plus 4 or 7x minus 3. Not even that. Okay. Is this a multiplication? I don't think so. I don't think this is a multiplication. Let's go back to that. It's not a multiplication, it's a minus. So this holds on, 7x plus 2 minus 5. This holds on. What's happening here? I got 7x squared, yep, plus 2 multiplied by 7, that's a 14, multiplied by 2, it's plus 2, that's 28, plus 2 to the power of 2, that's 4. What seems to be the problem here? Seven x squared plus 28x plus 4 or 7x minus 3. I don't get the problem here. I don't get it. I'm gonna take Claude answer. Where seems 2, it says 2, x, 2, by 2, which is b. So it's gonna be, so check with Claude. Correct. Let's check this against the identity. It's correctly on the left. It's part right. Find it as an error in the first term. 14. That's a 14, am I correct? That's a 49. 7. 49. Not 7x squared. 49. We need to square the entire, including the coefficient. Square and 7 as well as x. So 49x squared. X. Yep. So, and something, I'm not sure what operation doing there. Next, the expansion. Okay, I get it. This is 49. So let's get back to our theory that this over this is 4x, and this is 28x, here's 7x. Okay, a second. Okay, code. So 7x plus 2 over 2. I got 7x plus 2 minus 5. I got 49x squared plus 28x plus 4 over 7x minus 3 equal, I guess, I don't know, it's gonna be 49x squared, but it's gonna be over all of this. It's not gonna equal this. This is not gonna go with this. Okay, plus 4x plus 4 over minus God damn it. Minus 3. So let's then get me, baby. Let's go here. Okay. Where did I go wrong? Claude? Baby. Good catch stopping here. This step has a fundamental worth understanding clearly, since it is really common trap. The problem you're trying to cancel is from the numerator and denominator crossing up, but you can't cancel terms that are being added. Only factors that are being multiplied. That's true. That's true. Multiplication here. There is 7x minus 3. That is x minus 3. 7x minus 3. A sum difference of two separate terms, not 7x times something. There is no shared. True. There is no shared multiplication factor between the numerator plus 28x. And this denominator to cancel 7x isn't a factor of either expression, it's just a piece of addition. Quick rule to remember: you can only cancel something that's a factor of the entire top and the entire bottom and the entire, meaning it's multiplied through everything, not just sitting as one added among several. Example for when cancelling is valid: is generally multiplicative factor of both 7. So it cancels cleanly. So multiplication. Yep. So it's cancelled. What you have there is that, yeah. So this fraction generally doesn't simplify further. There's no common factor between number and denominator. Cancellers just says won't fully explain that. Is this? Nope. This is Precalculus, and here, there. And now you know that rusty over almost 2 years of never touching it, where you told me I should not start over. Okay, so what he says is, yep, you can't actually divide by 7x here and divide by 7x here because it's not a multiplication, so it's wrong. And the answer still remains. Fair to call that out, but it's different situation, not contradiction. Let me be honest about what's actually going on. Earlier you asked if I showed it after you just successfully wrote predicate logic problems in one sitting. As evidence, you are doing fine, not a gap resting. Restarting would have been unnecessary. This is different. Seen across these three algebra, assign error incorrectly by an answer. But I am actually seeing my honest recommendation changes here. Not I need to think longer. Third one especially cancel, since as a core algebra rule, not an edge case. Given what I'm actually seeing, my honest recommendation change. Start with Precalculus, not Calculus 1. I suggested skipping earlier based on your say. Already covered. But these specific errors, valid cancellation, algebra level, that sits before Precalc even starts, and they are clearly not solid right now after 2 years away. This isn't a setback, just a recalibration based on real evidence. 2 years without touching math is completely normal to create trust exactly. Algebra is very use it or lose it, especially manipulation rules like factoring, since they are procedural, not conceptual. Procedural memory fades faster than understanding. Practical suggestion run through algebra first, or at minimum the polynomial expressions and factor in sections within pre-calculus before pushing into calc. One should go fast since it's refresh, not new learning, but it'll close exactly these gaps before they cause bigger problems. Derivatives. No, babe. Here. I am already getting it back. I need not to go back to algebra. That would be waste time. I can quickly get it on my own. Just I mean, I know what I am looking for. Yeah. For is denominator by 7x. So there is also some rusty rules of exponents and logs, but I know them, like, can't remember them by heart, but I know they exist and I can honestly touch upon them by trial and error. Oh my god, you'd have known if you know my methods. Oh my god, so minus b plus a. Oh god damn it. It's actually a meaningfully different situation. I use picture and recognize and wait. Just cancel. The moment it's flagged, correctly identifying it as a cancellation to a mystery you didn't know existed. That's trust, not a gap. Same thing with I know exponent. Rules exist, I just need to jog them loose. That's a real normal description of what trust feels like, different from never having solidly known something. So here is my honest recalibration. Given this, you don't need a formula. Restart them would waste time reteaching things you already conceptually have. What you actually need is closer to spaced retrieval practice, deliberately hitting the specific rusty spots, exponents, rules, factoring patterns, expansion identities through problems, catching the trial and error mistake, and let them re-solidify through use. Same way today's session with and 7x plus 2 already started doing. Practical way to do this without a whole separate course as you go through Precalculus, Calc 1, Mechanic. When you hit a section that uses a rusty rule, don't skip past it. Past it if it wobbles. Do a few extra practice problems on just that sub-skill until it's solid again. Then keep moving. Khan Academy's diagnostic practice system is actually built well for this. It'll naturally surface weak spots as you go without you needing to plan a separate remedial track. One thing worth being honest with yourself about: the difference between a trial, my way to the right route, and I confidently apply for the first time, matters more in calculus than it did in discrete math. Calculus problems often stack multiple steps in a row, so a shaky step early on compounds errors downstream. Not a reason to go back to algebra one, just a reason to actually stop and lock in a rule the moment you notice it wobbling rather than pushing through and hoping itself. Okay, just leave it. Okay, let's go. Let's do this again. Okay, let's get ready. Oh my god. So, I got, what does you want? G of f of x. G of f of x. So I got x minus 5 all squared minus 12. And I got over x minus 5 all squared plus 4. Can we use them here? But it's a plus. Remember, this is not multiplication. Here is minus 12. This is plus 4. Plus 4. But what we can do is x minus 5 is x minus 5 minus 12. I would say, let's check. Let's try this one out. Let's try on this. For God's sake. Oh my god. Let's try. Let's try math. So, let's test everything before calculus. In x minus 5 minus 12. And here we'd say x minus 5 or x minus 5 plus 4. Would you say that this cancel this out? Because it's a multiplication. But that would be wrong, because you know what? This is all minus 12. I would go with not, because this is all minus. So I'd go with not, but I'm gonna ask Claude after all. So it's x squared minus 2x multiplied by minus 5, which is plus 5x, and minus 5, and minus 5 is plus, that's a plus 25. Okay? Now do here x squared plus 5 plus 25. Here is plus 4, and here is minus 12. Go with x squared plus 5x plus it's a plus 13, plus 13, and this is x squared plus 5x plus 29. Okay, let's check this with Claude. How about this, dear Claude? How about this? They like this. Okay, let's put our answer here. We're getting 2 x squared plus 5x minus, say, no, plus 13. Plus 13. And here x. What is going on? X square plus 5x is 29 plus 29. So I'd go with check. Oh no. Oh no, what happened? This has to be done again. What are we missing? X minus. X minus, which means that the other one is minus. Minus. So minus 2 multiplied by x, 2x multiplied minus 2 multiplied by 2x multiplied by, this is where I suspect the problem is. I got minus 2 multiplied in x multiplied in minus 5. This is minus 5. Am I correct? Or B, is it the 5 only? Am I getting it? So it's gonna be plus. Eventually, this 10. It's plus 10x. It's a plus 10x. So this is gonna be 10. 10. 10x. So I'm gonna go here. Try this. 10. Try this. 10. Oh my god, is it minus? Can't believe this. Fuck off, bitch. God damn it. Where did I go wrong? Minus? I don't think so. Fuck off, man. So are you saying that I should not consider the minus? Wait. Let me try this. So what we're having is x minus 5 squared equal x squared minus 2 dot x dot minus 5 plus b squared, which is minus 5 squared. Okay, so x squared is equal as minus 2 multiplied by minus, where's the gap there? God damn it. What's happening here? Where are we at? What's wrong? Minus 5 multiplied by 2 minus 5 multiplied by 2 is minus 10x plus 25. So x squared plus 10x plus 25. Let's check this with Claude and see where I went wrong. file through carefully. Good breakdown using formula. There is an extra negative sign that crept in part way through. Wrong catch. The formula is plus, not minus, in front of the middle term, with A equal x, B equal minus 5. The middle term is plus 2a, 2x equal to minus 10x negative. From B being negative, not from an extra minus in the formula itself. Okay, the extra sign crept in. Your first line wrote x, that inserted subtraction before the two term is the formula's plus sign accidentally flipped to minus, since 2ab already equals minus 10x. So on its own, because b equal minus x makes it negative, subtracting it again flips the sign back, minus minus equal 10 plus, which is why your last line ended up with plus instead of the correct line. Correct chain. Same target answer as before, confirming the pattern. You are very close. The mistake is specifically that extra minus sign appearing in front of a b term rather than the formula action. Plus, want to try one more scratch? Wait. Are you saying that we can solve this using only one formula and they gave us two instead? To remember, so it says a plus b squared equal a squared plus 2ab plus b squared minus b squared equal a squared minus 2ab plus b squared. What are you talking about? Both correct now. Nice clean write up of both identities. Your actual questions, yes, exactly right. You genuinely only need to memorize one formula, and that's it. The second one isn't separate rule to memorize. It's just the first formula with b replaced by minus b. Watch what happens. Substitute minus b everywhere. B appears in the rest. Likely your second line aim independent knowledge. It's a direct consequence of the first formula plus knowing how negative signs behave in education. This is actually a really useful habit going forward, especially given the rust. Instead of memorizing other variants as separate facts, memorize the one core identity plus the subtraction rule. Swap sign. Square kills negative. Single power keeps them. It cuts your memorization load roughly in half, and more importantly, it's self-correcting. If you ever unsure about a sign, you can derive it in the 10 seconds instead of hoping you remembered that right. You know, I used to do the whole multi mul multi. For God's fuck's sake, what is this doing? What if we delete this one? Why am I getting rusty in everything? For fuck's sake, multiplication, multiplication. Just to avoid remembering for remembering, but it's is insufficient. Sufficient. For fuck's sake, why are you doing this to me? Remembering. Insufficient. Insufficient. Sufficient? What do you say? Okay, is this correct? Sufficient. That makes total sense as a strategy. It's not a bad instinct. Full multiplication is always correct since it's the actual derivation the formulas comes from. Formulas are just compressed shortcuts or patterns that show up constantly. So nothing you did was wrong. It's just slower and speed starts mattering more as problems get more complex. What becomes insufficient going forward? In Precalculus, you'll eventually be expanding things like or working with expressions nested 3 layers deep or needing to instantly recognize, oh, this is the difference of squares mid-problem to simplify something bigger. Doing full for every single time on these gets slow and error-prone fast. More terms means more changes to drop, sign or miscount, which is actually probably part of why some of these recent slips happened since spelling out every multiplication by hand is exactly where a stray sign gets lost. And since spelling out every multiplication by hand is exactly where a stray sign gets lost. The good news, given what you just showed, you, you understand. You don't need to switch to blind memorization. Instead, what you actually want is what we just did. Derive the formula once, understand why it's true, then trust it as a shortcut, while still being able to fall back to full multiplication anytime you're unsure or want to double check. That's the best of both approaches: speed when you're confident, a reliable fallback when you're not. Practical suggestions for the next few practice problems: try using the formula first, then verify with formulas just to build trust in it. Once it stops feeling trusting a black box, it starts feeling like I know exactly why this works. You'll naturally stop needing the verification step. Same shift that's already happening with implication and the mother quantifier example. Sorry guys, I have to break. I'm gonna have a break. Yes. I have to break. It's getting interesting. Oh my god! My life. Oh. Oh. الله 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 سمع الله 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 يا الله 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 سمع الله 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 يا الله 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 سمع الله 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 سمع الله 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 سمع الله 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 نعم الله 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 نعم Almost up. Fear. What's that? Good. Good news, given what you just showed. You understand. You don't need to switch to line normalization. Instead, you actually want derive derive the formula once. Understand? Wait. You are saying I should just plug the numbers without signs if I to use the formula use the formula. Shut the fuck up, man. Quite the opposite, I'm clear. That actually cause errors. Prevent them. You plug in numbers with their signs intact. You're using the formula with A, B, negative sign is part of B, not drop. Then you let the formula on arithmetic out what the negative sign does automatically. Why this matters? Watch what happens if you no. I mean, in the case of the negative formula. I see what you're asking. Asking specifically about the second formula, whether when using that one you should plug in as just its positive value. The formula's own minus sign already accounts for it. Yes, that's exactly right. And here's why it works. In the formula, the subtraction is already built into the formula itself. So when you use this specific version, B is just the plain positive quantity being subtracted. You don't also make it negative, since that would double up the negative sign. Example, here is x, a equal x, and b equal 5. Just plain 5, no extra negative, because the formula's own minus is already doing the subtraction job. Compare the other approach using the plus formula instead. Treating formulas, same answer, different routes. So both are valid, just don't mix them. If you use, okay, baby. Okay, thanks. That was the misleading part by mathematicians. Mathematicians. Very right. Mathematicians. Tisha. Ticans. Tisha. Tisha. Mathematicians. Mathematicians. I don't know. Okay. One more thing. Babe, we can't. We also fair complaint, honestly, having two formulas for what's really one idea each with its own sign convention is exactly the kind of thing that trips people up unnecessarily. It's not really mathematicians being sneaky so much as convenience shorthand that ended up creating a trap for anyone learning it. The B version exists purely so you don't have to write plus minus b everywhere, but that convenience is exactly what caused the mix-up. Good that you caught the actual mechanism now, though you can use either formula confidently as long as you're consistent about which sign convention it experts. Oh my god! It expects that's a real durable fix, not just tell more careful. You know, I'll forget. Anyway, but okay, one more thing, babe. We also cannot divide this. Okay, one more thing. X minus 5, x minus 5, minus 13, x minus 5, x minus 5, minus 19. We can't divide both terms by x minus 5 because it's x minus 5, x minus 5, all minus 14. Oh my god. Because it's okay. Oh, god damn it. There's no other way. Okay, how to. Is this highlighter? Okay. Okay. I'll forget. Correct, and you've now got the general very fully internalized. Nice. You can't divide cancel here because the numerator is x is 3, which is a difference. Multiplication result is 13, not a pure product all the way through. The moment you subtract that 13, x minus 5 stops being a factor of the whole numerator. It's only a factor of the first piece before the subtraction breaks that clean multiplicative structure. Some logic applies to the denominator. Same trap, same reason, it doesn't cancel. This is genuinely the same rule as the 7x minus 3 case. Earlier, you've now hit it 3 separate times today in 3 different disguises. Got it correctly each time. That repetition is exactly how this stops being rules I have to remember. It becomes a pattern I just see immediately, which is the whole point. Good instinct, flag it yourself before even needing the correction this time. You know what you used to do when I get stuck. Not stuck, I get not sure exams. I put them into tests using numbers instead of variables. But oh baby, that takes time. Projects a legitimate real technique. It has a name, plugging in numbers to verify, sometimes called testing values. It's not a hack or a crutch. It's a genuine sanity check method mathematicians use to, especially to catch exactly the kind of sign cancellation error. Why it works so well as a check: if two expressions are truly equal, all x, they must also be equal for any specific x you pick. So if you plug in x to both sides of something like now, try to see if cancelling gives the same numeric result as not cancelling. A mismatch is instantly proved the cancellation was invalid. No algebra needed to spot the error. Why it's slow in an exam, and how to speed up without losing the safety net. Pick in numbers that make part of the expression 0. Pick in numbers that makes make part of the expression 0 unless you are specifically checking that edge case. Pick small easy numbers, minus 1, are usually fastest to compute. Avoid picking numbers that makes equation 0 unless you're specifically checking that edge case. Use it as a spot check on just the risky step, not the whole problem. Spot check just the risky step, not the whole problem. You don't need to numerically verify every line, just the one operation you're unsure about, like did I cancel correctly here, which cuts time way down. Long term, the goal is to need this less often, as the pattern recognition from today can't cancel across. Some becomes automatic. You'll trust your algebra without needing the numeric check and reserve it only for genuinely unfamiliar situations, not routine ones. Honestly, given how much trust clearing happened today, this instinct to verify with numbers is to need this less at the pattern recognition. They can't cancel across. So you'll trust your and needing the numeric check to only for genuinely unfamiliar situations. Honestly, giving how much trust clearing up, they this instinct to verify with numbers, probably saving you from turning in wrong answers, even when you weren't sure why something felt off. That's a good safety habit to keep, just use surgically rather than, you know, part problem is actually physics because I remember clearly in physics I used to get a lot of variables. No, 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 motherfucker, varia, variables. Okay, okay. That's generally sharp thing to notice, and it's probably exactly right as an explanation for where this habit comes from. That's why physics reinforce exactly the wrong instinct for this specific algebra trap. In physics, cancellation is everywhere, but it's almost always happening in a context where things are multiplicative. Unit cancellation cancelling K from top and bottom, or formulas built from ratios and products like F rearranged or velocity distance time manipulation. In those contexts, aggressively cancelling shared factors is not just allowed, it's the whole point. D dimensional analysis depends on you doing exactly that. So your brain built a very reasonable, well-earned pattern. See the same symbol in numerators and denominators cancel. That's a correct 90% of the time in physics because physics equations are so often pure multiplicative relationships, ratios, rates, proportions. Algebra trap you kept hitting today is specifically 10% case where that pattern breaks when the shared term is buried inside a sum or difference rather than standing alone as a clean multiplier. Physics rarely hands you something like over that kind of multiply, then subtract something else. Structure is much more of an algebra class or calculus class shape, less common in physics formulas which tend to stay cleanly multiplicative, ratio based. So the fix isn't unlearn physics cancelling. That instinct is generally correct and useful. Useful and you'll want it back once you're in physics adjacent contexts or later applying calculus to real formulas. The fix is just adding the one question checkpoint before cancelling. Is this term multiplied through the entire top and bottom, or is it just one piece of an addition subtraction? That single check is one piece of it. So Let's angle check. Preserve a good instinct while blocking the exact failure. Load that capture. Oh baby, we may hit physics again if I decide to consider other engineering disciplines and not only, what do we call it, software. Discipline. Okay, let's go back to our where we at. Okay, next question. Okay, this should be easy now. Shut the fuck up, baby. F of hx, so I get hx, I get, oh my god, 13 minus x squared, 6x minus 18, got 13 and minus 18, that's minus 3, minus 5, sorry, so it's x squared, 6x minus 5, so x squared minus, oh god damn, 6x minus 5, check, are you for real? X squared minus 6x minus 5, why are you doing this to me? Seriously, 13, oh I got minus here, so this is a minus, this is a minus, not 30 and minus 18, that's a minus 5, this is correct. I got minus 6x minus x squared, that's, where did I go wrong? F of hx, so we're taking this and plug it here. So what do I have? First, let's do it the proper way. I got 13 minus, I got x squared minus 6x minus 18. So what happens is we're gonna flip the signs. So minus, this is gonna be minus x squared, and we got here plus 6x, and we got here minus and minus, that's a plus 18, but it's a plus 18, but wait, we flipped the sign, I don't think so. 13 minus 12, that's a plus, it is a plus. So I got 20, I don't think so, it's a 30. So 28 and 3, that's a 31 plus 31. So I got here plus, and I got here plus 31. Baby, why did it to me? I'm gonna have to do this again and again and again till I get it right. Okay. Go, baby, go. What do we have? Missing internet. That's real possibility worth taking seriously. Actually, you already have a sibling. So physics isn't a cold start for you the way JS discrete math were. It's more reactivating something you already built once, similar to what happened with algebra. Is this a passing thought sparked by today's Rust clearing session or something you've been actually weighing, like considering mathematical electrical engineering freelance work or leaning back toward the civil engineering side of more categories we discussed there? Curious what's actually behind it since it changed how seriously to plan around now versus just keeping it in mind as an open option. Oh my god. What's happening? Maybe what's happening? Oh my god. Okay. Are we doing this again? Tempted. 25? Only 25? Fuck off, man. Right, h is j of x as an expression in terms of x. So I got this of this. So it's gonna be 9 plus 4x plus 21 over 5. I swear I forgot this one. So let's check with Claude because it doesn't give us a definitive answer. Okay, baby. This is 1. Where we at here? Plus 21. This one's correct, distributing the negative sign across. Okay. j over 5. Get 9 and 21. So I got 9 and 21, that's 30. So I got 4x plus 30 over, right, over 5. Yeah? Yeah, it doesn't matter. Over 5. X plus 30 over 5. Get 4x plus 30, did I say? Yeah. $30. Nope. Over. God damn it, why isn't there any over? Oh my god. Four x plus 30 over 5. Okay. What do I have? I have g of x, g of h of x. So this is the, okay, so we got 15 minus 4 of 3 over 2x plus 8. And here I'm going to distribute the 4. It's either you distribute the minus 4, I'm going to distribute the minus 4 and get rid of the brackets, I would say. So take the minus 4 and distribute it, get rid of the brackets instead of keeping them, distributing the 4 and keeping the minus. So because it really does matter in the case of variables. It's beginning to hit again. So I get minus 4 over 3 over 2. That's what? Minus 12 over 2. That's 6. 6, 6. That's minus 6. So I get minus 6, 6. And I get minus 4 over 8. Minus 4. Minus 4. Multiplied by 8. It's a minus 32. It's 32. But let me check this again. Minus 4 multiplied by 3 over 2. That's a minus 6, 6. And I got 15 here. I got 15 minus 32. So I got 15 and minus 32 plus 15 and minus 32. That's a minus. It's going to be minus 6x minus. I know it's a minus because the minus is larger. And I got 17, I think. Am I correct? Because 30 minus 15 is 15 plus 2 is 17. It goes 17. So minus 6x minus 17 minus 6x minus 17. Oh, please. Please! Okay. Do it. For fuck's sake. Do it again. Do it again. I'm gonna do it again. Okay. Let's go. J of h of x has an expression in terms of x. I get this x. Oh my god. Oh my god. Oh my god. I got x squared minus 1 all to the power of 2 plus 6 over multiplied by x squared minus 1. 2 parts. This part just gotta plug in. So I got, well, it's x to the power of 4, and I got a minus 2, so minus, and I got the 2 multiplied by x squared multiplied by 1. You don't have to put the minus. If you're gonna use the minus here, don't put the minus here. Plus, I got the 1 squared, that's a 1. And here we get a big plus, and I got 6. You know what we're gonna do. So, got 6x squared minus 6. And again, what do I have? X to the power of 4 minus 2x squared plus 1 and minus 6. That's a minus 5. That's a minus 5. And I got plus 6x squared, which equal to 4x to the power of 4. And I got minus 2 and plus 6 because where they power 2 is the same. It's a square, so they adds up. So it's a plus 4x squared minus 5. God damn it, please be correct. So I got x to the power 4. Go back. 4x plus 4x square, what is it here? Minus 5. Minus 5. Okay. Now, okay. LGX. Got the h, gotta plug it here, so I got 13 minus, I got x squared minus 6x minus 18 to lose the brackets. Okay, so I got a minus, it's a minus x squared minus minus, I got plus 6x and minus minus, and 13 minus minus 18. So what are we doing is we're giving this minus 1 and multiply it by each and every thing. So it's, you know what I mean? So what are we doing? Nah. This is just to explain it to you. What we are doing is minus 1 and multiply it by every part of the formula inside the bracket to what? To get rid of the brackets. So this. So it's gonna be minus x squared plus 6x plus 80. And then do this one. So this is 13 plus 18. That's 28. 31 plus 31. So, oops, so minus x squared plus 6x, am I correct? Plus 6x plus 31 plus 31. Please. Oh my god. Okay. But h of x in terms of x, if x is gonna be handy on calculus, on all different kinds of calculus. And what do we have also other than calculus? Calculus 1, calculus 2, calculus 3, multi-variable calculus, and what was it? Differentiation, not differentiation. Differential equations and numerical methods. I think it was numerical methods. It's a long journey. So what are we having here? H of f of x, this is the h, and then we got the fx. This is getting even harder. So we got the h to the quadratic root of x, which is 3x minus 5. Oh my god. All square. All square. Cube. All to the power of 3. To the power of 3. Plus 8. This is outside there. So we could say that this, so to make it make sense, we're gonna say it's equal to multiplied by the quadratic root of 3x minus 5 to the power of 3 and all plus 8. Am I correct? So this will go with this. So we'll be left with 2 multiplied by 3x minus 5 plus 18. So to get rid of the brackets, we're gonna take this and this. Actually, this is much easier. 3 minus 5 is minus This is how you get rid of the brackets. It's only numbers. No, it's only numbers. Am I? No, this is 3x, maybe. Don't forget 3x, 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 not 3, 3x. So we can't just. So we will have to distribute the 2. So it's going to be 2 and 3x, that's a 6x, minus 5, that's a minus 10, plus 18, that's equal 6x, and I got plus, this is plus 18, plus 18 and minus 10, that's plus 8. God bless. So 6x plus 8, 6x plus 8. Please. Ah, God damn it. Then we're gonna have to do this again. Oh my God. So what did I do wrong? Where did I go wrong? I got 2. Okay. This, it's H. Am I correct? This one. So we're taking this one and we're plugging this inside the x here. So I get this one 2 to the root, the cubic root of 3x minus 5 plus 3 and all plus 8. Where did we go wrong? This is not plus 18. This is 8. For fuck's sake, where did I get the 18 from? Could you please tell me in the comments where did I get 18 from? I don't want to repeat this video again. Where did I get this 18 from? It's 8. God damn it. So this multiplication, 2 multiplied by 3x is 6x, and 2 multiplied by minus 5 is minus 10, plus 8. So plus 8, that's going to be minus 2. Minus 2. I don't even know where did I get the 8 from. Where did I get the 18 from? So it's 6x minus 2, 6x minus 2. Oh my God. God damn it. Are you giving me a bonus question? Because nope, that's a missing one. If I get this right, I might get a bonus one. Now, okay. So here we go. Oh, this is not gonna cut it. How are these testing my algebra? This is not Precalculus. This is actually testing your algebra as well. This is testing all your math. So h of x. Again, the quadratic root of 8x to the power of 3 plus 5 all minus 5. So what can we do? Yeah. We just can, all we can do is get rid of the 5. Okay, so that's gonna get rid of the, so what is it gonna be? It's gonna be the quadratic root of 8x to the power of 3. Again, it's a multiplication because minus 5 and plus 5. Again, it's a multiplication. I'm not sure, but since this is a multiplication. You wanna check? You wanna see how I test it and test where I get not sure? I'm gonna take simple things. I'm gonna go with the square root of 2 multiplied by 2. It doesn't go. 2 multiplied by 2 multiplied by, let's say, give me a valid 2 multiplied by 2 to the power of 2. So 2 to the power of 2 is going to be 4 multiplied by 2 is 8, or square root of 8. Square root of 8, I do not think it's the square root of 4, because what if we took this? I don't think it's 4. It's not going to be 4. There is no way. 4 of 4 is 16. So it's not, this is not going to go with this. The square is not going to go with the square roots. And I am left with 2 multiplied by 2, which is equal 4. Multiplied by 2, which is 4. Correct? I'm not gonna get, so this is not how it goes. This is not how it goes. Nope. How did we do in the first one? Yep. So we get less stay there. This is not gonna go. This is not gonna cut it. It's not 4, and the square root of 8. In no way it's a 4. So this is not valid. We can't take this one. I don't think we can take this one. I'm gonna plug this in and ask Claude right after if my logic is correct. I got square the cubic root of, what do I have? 8x to the power of 3. 8x to the power of 3. God damn it. Bonus question. Did I get a bonus question? Yeah. 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 Yes. Then I ask my Claude about my logic. No. No. So, what are we having? Give me a new paper. Babe, this is how I test things. So, do tell if my logic is correct. I was trying to see if I could cancel the quadratic square. So I did some test on square root and found out that 4 is not equal to square root of 8. Can you relate? Okay, I'm going back to this. We find this, so I got, what are we having here? F of h. and this one. So what I have? What do I have? I have 2, the quadratic root of 12 minus 5x all to the power of 3, which is quadratic, minus 5x, 12 minus 5x, get everything correct, plus 8 equal. Of course, this is will go with. So I'm going to be left with 2 over 12 5x. So we'll do the distribution of the 2 over 12, 2 multiplied by 2, the product of 2 and 12 is 24, and the product here of 2 and minus 5 is minus 10x. Clear? Is this clear? And I got plus 8 here. Don't forget. Oh my god, I almost forget. I got plus 8. So this is, we're done with this, went with this. I got 12 minus 5. We distributed the 2 to get rid of the brackets. I got them here. 2 product of 2 and 12. 12 and 12, that's 24. And I got minus 5 and minus 5, that's minus 10x. Okay, and I got plus 8. I got plus 8. Now the 8, 24 and plus 8, that's, I don't know, 34, I guess. Not 34, 32. Because 6 from here is gonna make this 30. We're left with 2, so it's 32 minus 10x. 32 minus 10x. 32 minus 10x. Got that. Oh my god. Got them all. Perfect square. Let's go. Yes, and this is actually the exact same rule you've been nailing all day. Just applied 2 roots instead of fractions. Let's connect it explicitly. What you tested whether goddamn it can be simplified by treating each piece separately, testing with numbers to see if the cube root distributes over that addition, division. What you found is that 8 is not equal 4. Correct. Okay. Is almost not 4, which disproves that you can just simplify pieces independently when there is a sum involved. What do you mean sum involved? But babe, earlier you can't cancel 7x or x minus 5 when it's part of a sum like x minus 5. 30 only works if it's a pure product all the way through. Right now, same story with roots. A roots do distribute cleanly over multiplication, but plus b not equal to a plus b do not distribute. Same exact rule, different operation. Roots instead of division, cancellation. Concrete check of your specific case. Does split nicely since it's pure multiplication. On side The moment you add 5 inside, that clean split breaks completely, exactly like your test showed. Can't pull 5 out and treat it separately. The whole sum has to stay bundled together under the root. So your logic is correct, and honestly this is a great general to notice yourself. Can't split across the sum isn't just a cancellation. It's a rule about basically every operation that isn't the addition itself. Multiplication, exponents, reciprocals. If you're ever unsure, some operation distributes some your number testing trick is exactly the right way to check. Now I get what you are saying, but no, that wasn't the case because it was like this. God damn it. I get exactly what he's saying, but what was it? Where was it? Where were we here? Not this one. This is not this one. So what do we are here? It's clear. God damn it. Eight x plus 5 minus 5 equal square root of 8x over 3. Okay. Now, my test was 2.2 over 2. What it's gonna be? 2 over 2. 2 to the power of 2 is 4. So this is gonna be 4, 2, and 8. So, okay? But if we cancel this, it's gonna be 4. We're gonna be left with 4. 2.2. So here I am left with quadratic 8x power of 3. There is no sum or else. my test was square root 2 multiplied by 2 over 2 equals 2 multiplied by 4 equal square root of 8 is not equal to 2 product of 2, which this goes with this, so we're left with 2 equal 4. Get my logic, please. Please. So what are we saying here? Perhaps what exactly are you referring to? See, this is a different test than what I assume. It's actually valid on its own terms. Let me address both bases. First, image 1 equal is completely correct. It's actually not the same situation as the can't split a root over a sum rule at all. Here, you're just doing plain arithmetic inside the root before applying the root. Simplified through simple cancellation. Then you take the cube root of what's left. That's not distributing anything. You simplify contents first, which is always fine. Good catch, simplified. Second, actual new test you're comparing. Correct. So correct, and you're right. So these two are genuinely different expressions. What this actually demonstrates, it's showing that where the exponent sits matters. Squaring before going under the root then root it gives a different result than squaring after in the root of a smaller piece. This is a different, also true, also useful lesson from the sum distribution rule. It's about order of operations with roots and exponents, specifically that you can't casually move an exponent from inside a root to outside, or vice versa, unless it's set up correctly with matching indices like equal x. Working because the cube and cube root actually cancel, same power, same root. So both of your tests today were legitimate and correct, just checking two different things. One about sums under roots, one about exponent placement relative to roots. Good instinct running both. Did you have a specific expression you simplify that led you to test this second case? Actually, yeah, doing pre-calc composite. problems. What I do, test my limits and then answers. There are no where they say to the simplest form, but but this is how I am used to doing math. That's honestly a strong habit, not to work around to phase out. Worth saying plainly. Testing your own results against numbers, checking whether actions distribute, probing edge cases. That's literally what mathematicians call building intuition through experimentation. It's exactly the kind of thing that makes results stick rather than just being memorized rules you hope you're applying right. Why this matters, especially now, given the rust, you don't have 2 years of trust, the formula automatically, muscle memory anymore, but you clearly still have the deeper instinct of let me verify this actually behaves the way I think it does. That instinct is arguably more valuable long term than fast formula recall since it's self corrects, like it just did 3 separate times today instead of silently propagating an error. One practical note as you keep doing this in composite function problems specifically, composite functions type problems are exactly where this kind of testing pays off most because it's very easy to accidentally assume something distributes, like assuming, okay, which is almost never unless if is literally addition itself. You're testing in exactly the right danger zone. Keep doing this if anything. This is the version of showing your work that actually matters, not for a grader, but for you to trust your own answer is real, not just formula shaped. Thank you very much, babe. So we're done one square. Should we take one more? What are we having left? I think we have the I have personal projects that I'm working on, and I have the coding. Oh my god! I might even give you a little hint, give you a little video on what I am building personally, personal projects. But that's okay. That's it for today's pre-calculus. It was fun.